This video will cover the build of a support table for a mostly printed CNC machine. This particular table design will provide a 48-inch by 48-inch work volume. The table is designed in such a way to allow for an interchangeable work surface. Each Z-beam is 60 inches long. It is made with two 2x4s cut down to 3 1/4 inches wide and one 2x6 cut down to 5 1/4 inches wide. 1/8 of an inch was removed from each edge in order to provide as straight as an assembly as possible. The table cross braces are made from a 2x6, 55 3/8 inches in length, and trimmed down to 5 1/4 inches in width. The ends of these 2x6s have been notched for the bottom of each Z-beam. Each leg is made from a 4x4 notched and cut to 32 inches in length. Note that these are pressure treated only because that's what I had handy. Normal dimensional 4x4 lumber would be fine here. The leg braces are 2x4s cut to a 3 1/4 inch width and are 24 inches long. The ends of both table cross braces should have 3 pocket screw holes drilled, as you can see. These pocket screws, along with 3 more on the outside leg face, will affix the Z-beam to the cross brace and leg assembly. Glue and clamp the leg and cross brace into place. I'm using a speed square to ensure the leg is square to the cross brace. You'll then drill pilot holes for the 2.5-inch screws that come next. Make sure that your screw holes don't interfere with the path of the pocket screws. Because the clamp is in the way, you can really only drill 4 of the 6 pilot holes. After you've installed the 4 corner screws, you could remove the clamp and add the 2 other pilot holes and their screws. Now on to the second set of legs. I have to apologize for the audio. My furnace is running, and it's kind of loud because I don't have one of them fancy wearable microphones. You get what you get. Excellent, Smithers. Oh, not wonderful. Okay, there's one. Let's go finish the other one. Okay, let's get the other side done here. A bit of glue, or a lot of glue. You probably can't see it, so you'll never know which I picked, will you? Make sure we are good and square. That's good. So let the drilling and the screwing commence. And there's another pair of legs. Wonder what's next. Okay, so now it's time to put the legs on the rails. The rails are currently upside down, because that's how I can put this thing together. Going to check my drawing again to make sure I'm putting this together correctly. Yep. It's really kind of tippy. And I do not recommend this if you're building one of these by yourself. Because you could get hurt just by the mass of the components swinging around and smacking you. Okay, so it's square-ish. Yeah, that's pretty good. Okay, so I need a shim or two. Okay, I have to shim this because when I was making this cut here, this notch, or not in this piece, but in this piece, I cut it a little bit too narrow. So what I have to do is to prevent the screws that I'm going to put in here from pulling it down, I'm going to go ahead and shim this with some offcuts that I took from all of these 2x4s. Okay, hopefully that angle will allow you to see what I'm doing a little bit better. So let's get some of this stuff out of the way. Put my glue down. Check my square. Okay, it kind of wants to fall off now. Kind of a problem. But it's one I can solve with a huge lamp. And the pocket screws. Okay, now we get to do the other side. I love these saws. They are awesome. This is Von Bear saw. Essentially what it does is instead of like a regular saw that cuts on the push, this cuts on the pull. Okay, let's go to the other side. I will save you the pain of watching me do the clamp up again. Check square one more time. Okay, let's see what that did to my squareness after I take this off. Yeah, not great, not great at all, but that one's no great shakes either, so. Okay, well, let's get the other legs on. That's not gonna work, is it? It might. Oh, there we go. Look at that. It wobbles all over the place. Yeah, that's safe. Not. We go. So the next task will be to do the pocket screws on the other side. And then we put these braces in, like so. I'm going to do the pocket screws. Okay, now let's go ahead and get the cross braces installed. Okay, off to do the other side. One more to go. Okay, we are almost done putting this thing together. Only a couple more things to add. Okay. The next task here is to install the cross brace. It's a really tight fit, so I suspect some hammering may ensue. Wow, look at that. And it's going to stick down just a little bit because this was not cut the same thickness as the other part. Okay. Oh, now do the other side. I know what I'm going to do. I'm going to cheat. Okay, what I've done here is just tilted the thing up. And that will give me access to get these last 3 screws in. Get in there. Okay. Ah, that thing ain't going anywhere. Which means I probably need it to go someplace. Because that's usually how these things work. Hammer! There we go. A little percussive maintenance fixes everything. Last 3 screws. Anybody take bets as whether or not I knock the box of screws on the floor? Or miss the screw entirely? 3 times. Okay. The completion of that is now allows us to do the almost final task. And to do that, I need to bring it down. The next task is to put wheels on. I need to put wheels on all the tools in my shop because I tend to move things around quite a bit. And if they don't have wheels, moving them is really damn hard. Okay, let's get this thing wheel side down. Oh, up. Very carefully. Ta-da! So I discovered last night, after I got the wheels on it, that I'm out of square by about 1 inch as measured diagonally, okay? For those of you that don't know, when you're trying to make sure you've got something square, you measure across diagonally both ways, and if both measurements come out the same, you've got a square assembly. Well, it wasn't square. It was badly not square, like there was 1 inch difference between the two measurements. So what I ended up doing is using some ratchet straps to pull that error out. I still have a small error, but it's only 1/8 of an inch. And I can't really adjust it any farther than that because the size of the notches in my ratchet straps are simply too large. It's either it pulls it too much or not enough, which realistically is okay. The next task I have to do is I have 2 panels for the machine bed that are 3/4 of an inch MDF, 24 inches wide. I'm going to use those to retain what the ratchet straps are doing. And I'll do that by screwing them along the outside perimeter here and along the center. There is a gap between the 2 points, or 2 panels here, and that is for, at some point, a water drain for the plasma cutting table that this should be able to accommodate as well. So, that being said, let's get on it. I'm going to cheat with my layout. Instead of using a tape, I'm going to use a thing called a rivet fan. Okay, this is basically what they use in aircraft when they're working on skin. They use these to correctly space or evenly space rivet holes. And that's what I'm going to use for this. So I will set it on my start mark here and just start making marks. Between the fan, the rain, and the traffic, this video is going to sound like shit. In Washington State, we don't die, we rust. See, rivet fan. Time to center punch. There we go. Next up, drill. Okay, gonna pre-drill my holes, and then we are going to start throwing screws into it. I'm going to use a 2-inch long screw because I really want this to stay down and not move and hold this whole thing square. I'm not going to use glue because if something damages this surface, I need to be able to replace it without destroying half the table. Fancy new square drive bits. Clamp to hold it in place while I work, just until I can get a couple of screws into it. Ah, I ran out of holes. So this side's done. Let's go that side. We are done. And the crowd is mildly entertained. Okay. Next, overview. Okay. Now that the table is done, let's see what's going into this build. First, we've got a box of 3D printed parts. These are the new style feet for the MPCNC. Everything else is the old style parts. All of these parts, with the exception of these new style feet, were printed roughly 3 years ago. This is how far I am behind on this project. By the way, for comparison, that's what the old foot looks like versus the new foot. Much more shapely design. This gets the job done. Okay, next, I've got a couple of packages. Belt for the drive. Let's see here. A priority mailbox. Wow, almost 3 years to the day. December 30th, 2016 is when I got this from the fine folks at viciousone.com. And I have absolutely no idea what is in this box. Something tells me I'm going to find out. Okay, we've got... Boy, that looks suspiciously like a vinyl cutter maybe, or a scribe or something. I'm not sure. Okay, and this is the display controller for the machine, and then just packing material. So, put all that back in the box. And then this package showed up December 24, 2016. Again, nearly 3 years to the day. Because, well, damn it, I got a lot of shit going on. And this box is going to have in it all of the goodies I need to build this printer. So we've got some all thread. I suspect that's for the Z-axis. Paper. Wire ties. Gee, this would go great with the other 40,000 wire ties I have. We have a box with what looks like a rough wrap discount controller in it. Oh yeah, it's got a Arduino Mega, and what the hell is that? BigTreeTech.com. Not sure what it is. It's probably rep wrap discount controller or something like that. Doesn't matter. I'm probably going to use a Rambo with it, but we'll see. So there's also some belt in here in the package, USB cables, miscellaneous wiring. The next box, a laptop power supply. And then we have got an absolute metric ass ton of 608 ZZ skate bearings. A bunch of what look to be 5/16 lock nuts, some more bearings, some GT2 belt drive gears, miscellaneous pieces of 5/16 hardware. And those look like number 6 screws. These are metric M3s for stepper motor mounting, really? Wow, okay. And there's some number 6 lock nuts. And there are 2, 4, 5 stepper motors. And these look to be pretty bog standard NEMA 17s. Yeah, those are pretty generic, but what the hell? They will get the job done, am I right? Okay, so now that I've got all this out of the package, I gotta put all this crap back in the package because I got more stuff to show you. Let's toss all this junk back in there. It didn't come out in any specific order, it didn't need to go back in any specific order. Okay, so we'll put that box right there. The next box I've got is for the spinny cutty thing. And that is one of these. This is a 400-watt spindle with an ER11 collet on it. And that includes some mounting hardware that may not get used. This is a speed controller. It's some packaging that makes it really hard to see, but it's a brushless motor controller, so I can control the RPM of the motor from the CNC controller. And I believe this is the power supply for it. Yep, this is the power supply for the 400-watt spindle. So that is really all there is to that. Oh, wait, there's more. There's more. To make all of this wiring that I'm going to have to do look neat, I've printed a pile of E-chain. This stuff is available on Thingiverse. If I can find the link to it, I will put it in the description of the video. This was printed at, I think, 3 times or 4 times the size. I printed it on my Artemis printer, pre-connected. There's, I think, 11 pieces to each chunk that I put together, but all this E-chain does come apart. And it printed out very nicely. I may need more at some point. If I need more, I'll print more. And finally, this is the model of plasma cutter that I'm going to be using with it. The company that makes this plasma cutter makes a tool head that is specific for CNC, where it is straight and does not have a handle on it, or a activation switch on the handle. So that is an experiment for another day. But first, I've got to turn all of this into a working machine. So that's what's next on the agenda. Actually, no, that's not what's next on the agenda. What is next on the agenda is the wood cutting plenum for this. And I will make a separate video for that, maybe. Thanks for watching, guys. Please subscribe.